Okay. So we're doing second half of the review today, guys. We went over basically chapter 7, part 1, mostly. We went through all of this stuff. We have not gone through chapter 7, part 2, which is acid-base problems. In some classes I did, in some classes I didn't, because depending on how much time I had. But I'm still gonna go over it, because if I didn't go over it with you, I'd rather it go over it with everybody to make sure. We did something like this already, in problem number 1. We have to write the products of the following reactants with their correct states of matter and also balance the equation. So just a reminder, it's always separate, okay? Always separate them, and it's always outer, oops. Outer, inner, right? So let's get the charges for each one. All right, and this is where we get the charges. So hydrogen, H. What's the charge of hydrogen? Mm-hmm. All right, Cl. What is the charge of Cl?
-1.
Mm-hmm. What is the charge? Let's find K. What is the charge of K?
1, +1.
Mm-hmm. And lastly, what is the charge of OH?
-1.
Mm-hmm. So now that we have the charges, we can put everything together on the other side. So we have H +1. Then we have OH -1. Okay. And do those charges balance, or do we need more of something? What do you guys think? Do they balance? Do we need more H? Do we need more OH?
They balance.
They do balance, exactly. So we don't need anything else. We just need HOH as it's written. Next one. K is +1. Cl is -1. Reminder, positive always goes first. No matter what, positive always goes first. Do those charges balance? Do we need more of something? Yeah, they balance, exactly. So we just need one of each. Okay. So we wrote the products. Okay, now we need to write the states of matter, right? So remember, the states of matter are the following. Solid, S. That means that something is insoluble in water. It won't dissolve in water. It will not dissolve in water. Then we have liquid. Remember, for liquid, we use it when we have water as a product, meaning H2O or HOH, right? Then we have gas, or G. We don't use that normally. Normally, that's when one atom is by itself and we have a subscript of 2 below it. So hydrogen gas, oxygen gas, fluorine gas, things like that. And last but not least, we have aqueous. That is when something is soluble, okay, or dissolves in water. Okay, so how do we decide this? Well, we look. So the first one is HOH. So what state of matter will we put for HOH according to this chart on the side? What state of matter would go for HOH? Let's see. Liquid, exactly. HOH would be a liquid. So we would put L. Now KCl, we have to look for that one because that one we have to look up in the solubility rules. So what solubility rules are those? That's page 5. Reminder, some of you have hard copies of this, some of you don't. So K is a soluble compound. Cl is a soluble compound, meaning both of these fall in the yellow section. They don't fall in any of the exceptions. So they are soluble. So for this, we would write AQ, aqueous. Okay, and that's the states of matter. Now, last thing we have to do is we have to balance this. Okay, we have H, Cl, K, and then we have OH. We have one H in the reactants. And then remember, this is separate like so as well. So we have one H in the products. We have one Cl in the reactants. We have one Cl in the products. We have one K in the reactants. We have one K in the products. We have one OH in the reactants, and we have one in the products. So this is all balanced. So that's also all done. And that's it. Are there any questions for these kind of problems? Trust me, like I said before, you are going to get a problem like this, so just be prepared. All right. So you have enough practice. B, C, and D are more than enough practice here. Okay, then for number 2, it says, what is the net ionic equation when a strong acid and a strong base combine? Just reminder, acids have hydrogen, right? Bases have hydroxide. Acids have hydrogen, bases have hydroxide. So when we have a strong acid plus a strong base combined, they will always form water, meaning they will always neutralize. Okay, they will always neutralize. So acid is very acidic, very low in the pH scale. Hydroxide is very high in the pH scale. And then so when you have something high in the, something low in the pH scale, something high in the pH scale, they will together neutralize and form water. Okay. Chapter 7, type 3. So types of reactions. So for this is all chapter 7. For these, you just have to tell me whether we have a precipitation reaction, an acid-base reaction, an oxidation reduction reaction. Okay, so how do we know? So this PowerPoint, I think I shared, let me just go back to it just real quick. Chapter 7. And I just want to make sure that you guys do have access to all of these PowerPoints, by the way. Let me see. Okay. And I just want to give you an example of each. Okay. So remember, acid and base reaction, just an FYI. So first, let's start with acid-base reaction, right? So an acid-base reaction is any time when we have a strong acid, which is something with hydrogen, and a strong base or OH, and together they neutralize and form water. Let me see. I don't know. I'm trying to look for something that I have here. So a strong acid and a strong base, like for example, this reaction right here, HCl plus KOH gives you water plus KCl. So anytime you see acid base like that, so if we look through this, we have like D right here. Okay, this would be a strong acid and a strong base, or an acid-base reaction, because we form water. Okay. An oxidation reduction reaction is when we find have a transfer of electrons from one reaction to another. And let me just hold on. All righty, I'm just trying to look for these. Sorry, guys. I thought I had a better PowerPoint for this. Let me see. Okay. An example of an oxidation reduction reaction would be like B right here. Because in this one, and I'll explain it how this one's at. In this one, when we have like a single replacement, normally single replacement reactions are our oxidation reduction reactions. When, for example, magnesium here plus oxygen is going to transfer its electrons over. Let me see. There's this one right here. This one's the one I wanted. So an aluminum and iron here are going to trade partners, and oxygen is now going to be with aluminum. So what's going on is aluminum is transferring its electrons over to iron, Fe, and then oxygen is going to have a new partner. So anytime we have a single replacement, so these are known as also single replacements. Okay, when one replaces another, so hydrogen in this case replaces zinc, and they switch partners, and that's when we have an oxidation reduction reaction. And I'm just trying to remember for precipitation reaction. Sorry, let me just go back to my key real quick. I know I have my key as well. It's been a long, let's see, there it is. Okay. Yeah, the first one, that's what I thought. Okay, so for precipitation reactions, this is a precipitation reaction. For these is when we have a double replacement, right? And they are not an acid-base reaction. So for double replacement reactions that are not acid-base reactions, we actually have precipitation reactions. So KMBA switch partners, SO4 and NO3 switch partners. And that's when we have precipitation reactions. So again, oxidation reduction, it's normally single replacement. So when we have one switches with the other, double replacement is usually precipitation reactions. Acid base, anytime you form water, it is an acid base reaction. All right. And those are it. Those are our categories. Okay. So what I would want you guys to do is, how about try just these last two right here? H and I. Try H and I by yourselves, please. All right, guys, let's look at H. H, what do you guys think H would be? According to these three, examples, which one would H best fall as? Precipitation, oxidation reduction, or acid base? What do we think? Zinc chloride plus magnesium gives you zinc plus magnesium chloride. What would that fall under? Sorry, I can't hear it. I can't hear you guys. Someone,
Oxidation.
sorry, what did you say?
Oxidation reduction.
Exactly, yes. So this is a single replacement because zinc and magnesium switch places. So this is an oxidation reduction. Good. Okay, how about I? Which one would it best fit? Precipitation, oxidation reduction, or acid base?
Precipitation reaction.
Yes, nice job. Okay. Any questions on chapter 7, part 3? Okay. Now let's look at some stoichiometry, guys. Okay, stoichiometry is very, very important. It's very important that we actually understand this. And just a reminder, you'll always have a formula. So just note, you'll always have a formula for a stoichiometry problem. It says, if 15 grams of CuNO3 react with 20 grams of NaNO3, how much NaCl can be formed and what is the limiting reactant? So these are stoichiometry. Not only is it a mass to mass, but it also is a limiting reactant problem, which means that you're going to start first with one of these and you're going to go to NaCl. Then you're going to start with the other one and then you'll go to NaCl2. You'll see which one forms less NaCl and that is your limiting reactant. Again, start with one, go to NaCl, start with the other, then go to NaCl again. Which one makes less? That's my limiting reactant. So we start by 15 grams of CuNO3, 2. Right? So if we look, we're going to use our reference sheets. Oops. Okay. So we are here. We're starting with mass. We're moving to moles. We're going to go into 1 mole over the molar mass. So 1 mole of CuNO3 2 over the molar mass of CuNO3 2. Meaning I need to know what Cu is equal to. I need to know what 2 N's are equal to because it's 2 N's. And then I need to know what 6 O's are equal to. Meaning I need the mass of each one. So that's when I use my page 1 and I find Cu, right? Cu is 63.55. That's the mass of Cu. N is 14.01. But just a reminder, we have 2 N's, so it's times 2. And then O is 16. I just know that one by heart because I use that one so much. It's 16, but it's times 6. So first thing, oh, I don't know why I did that. Oh, come on. Sorry about that. Okay, first thing is I want to know what 2 N's, so 14.01 times 2 is equal to. That is equal to 28.02. And then 16 times 6 is equal to 96. So we're going to do 96 plus 28.02 plus 63.55. Listen, you need to add them all like this because, and then a lot of people, this is where we mess up. We don't get correct masses. We don't count all the atoms. You need to count every single atom. Every single atom is part of the equation. So it's 187.57. Sometimes we only count one N, sometimes we only count one O, but we need to make sure every O is counted. So again, that's the first half. So we go back to this reference sheet. We went from the mass to the moles. Now we need to go from mole to mole, meaning we need to use coefficients from the balanced chemical equation. So it's going to be mole over mole. The mole that you want to get rid of, you want to get rid of CuNO3 because you don't want that anymore. Now you want NaCl. Okay, so you look for NaCl, you look for CuNO3. The coefficients are the letters, are the numbers that go here. NaCl has a coefficient of 2, so that goes at the top. CuNO3 doesn't have a coefficient, so that means it gets a 1. And then you keep going. And your last step is you're going to go from molar mass, from mole to mass. So you need the molar mass at the top over 1 mole at the bottom. So again, we're going to get molar mass, but this time we're doing NaCl over 1 mole of NaCl. Because remember, we want to go from CuNO3 to NaCl. So now I need the mass of NaCl. So I need to know what Na is equal to, Cl is equal to. Na is 23. Cl is 35.45. So 23, 35.45. So together, added together, plus 35.45. And this one doesn't have any little subscripts or whatever, so it's just one of each. And that would be 58.45 grams. Okay, so remember, you multiply by the top, divide by the bottom. So it's 15 times 1 divided by 187.57 times 2 divided by 1 times 58.45 divided by 1. That gives you 9.35 grams of NaCl. So you're not done here because now you need to start with 20 grams of NaNO3 and you need to do the same thing. You're going to transition all the way to NaCl, right? So that means the same steps. It's going to be 1 mole of NaNO3 over the molar mass of NaNO3. So again, Na, N, and then O3. Well, we said Na was 23, we said N was 14.01, and we said O was 16, but we have 3 now. So then we do 16 times 3 first. That's 48. And we're going to do 48 plus 14.01 plus 23. That gives us 85.01 grams of NaNO3. Then we do our moles to moles. Obviously, the top is going to stay the same because we do want to go to NaCl. The bottom, we want to get rid of moles of NaNO3, so that goes at the bottom. What do we have for NaNO3? We have a 2 as well, so a 2 goes at the bottom there. So that's a little different than the top because at the top we had a 1 because CuNO3 didn't have a coefficient. NaNO3, however, does have a coefficient. Okay, and then the ending looks identical to the top. You're going to write 50.85 grams of NaCl because that's what you want. You want 1 mole of NaCl at the bottom, and then you just do the math. Meaning, so now you're going to do 20 times 1 divided by 85.01 times 2 divided by 2 times 58.45 divided by 1, and you should get 13.75 grams of NaCl. Okay, so let's take a look at both of these numbers. Obviously, I mean, this is common sense. 9.35 is less than 13.75, right? We all know that. We all know that 9 is smaller than 13. So we go back to the original number. That means that 15 grams of CuNO3 is your limiting reactant. So when you write this, you would write CuNO3 is my limiting reactant. And that's it. Questions? All right. So what I want you to do right now, real quick, and again, we'll just see how far you get. I want you to try number 3 for me. Very similar to number 1. Try number 3 for me, please. Guys, just an FYI, I haven't dismissed anyone. I heard like 3 people already left. I have not dismissed anyone, so they will be marked absent. Again, you haven't been dismissed. Okay, I'm just gonna start 3 for you. If you're in the middle of it, just keep going. Because honestly, it's really important because I'm gonna tell you right now, you will have a problem like 1 and 3. And this is why I wanted to get through it at least today, because I do have more. Obviously, I want to go through percent yield, theoretical yield, and I want to go through a lot more next week. And next week, it looks like we're only gonna have 2 days each day. So I want to go through as much as possible. So yeah. So first of all, it says you have 71.24 grams of zinc, ZN, right? So again, it's going to be, you're going to go from grams to moles, meaning you're going to have 1 mole of zinc over the molar mass of zinc, right? And you have to look that up. And using your reference sheet, zinc is 65.39. So your molar mass here is 65.39 grams of zinc. Okay. And then you're going to go from, because, and again, you're going from zinc to zinc chloride, hydrochloric acid to zinc chloride. Zinc chloride, by the way, and it's right here, that's zinc chloride, ZnCl2, and you're going from zinc. So it's going to be mole to mole. And both of these don't have coefficients, so it's just going to be 1 mole, 1 mole. You want to get rid of zinc, so zinc has to go at the bottom. You want zinc chloride, so ZnCl2, that goes at the top. And then we're going to do the molar mass of zinc chloride over 1 mole of zinc chloride. Right? So now we want to know Zn, which is, we said is 65.39. Chloride we have up here, it's 35.45. I'm just stealing it from up there so I don't have to go back to it. And we do that times 2, right? Because we have 2 chloride, because it's ZnCl2. So it's 35.45 times 2, which is 70.90. And we add that to 65.39, and we get 136.29. All right. And so let's do that math. So it's 71.24 divided by 65 times 1 divided by 65.39 times 1 divided by 1 times 136.29 divided by 1, you get 148.48 grams of zinc chloride. Right? And then you do the same thing here again. And I know we are running short on time, but I just want to keep going with this. I want to get through this. We get 1 mole of HCl, and it's going to be over the mass of HCl. Just by the way, H is 1.01, Cl is 35.45. You add those together, you get 36.46 grams of HCl. Okay, then you do HCl, so you want to get rid of HCl. So HCl has to be at the bottom, and it's going to be 1 mole of zinc chloride at the top. All right. And then the ending is going to be the exact same thing, grams of zinc chloride over 1 mole of zinc chloride, because all of these problems end the same way. And then you just do the math again, 91.53 times 1 divided by 36.46 times 1 divided by 2, and then times 136.29 divided by 1, we get 171.07 grams of zinc chloride. So which one is less? Obviously the top one is less. Oops. Grams, sorry. It was 148 grams. Top one is less than the bottom. So what is your limiting reactant? You would just write zinc is my limiting reactant. Okay. If there is any questions, guys, just a reminder that I will help you guys to next week as well. Okay. All right. Have a great weekend, guys. See you next week.
Bye.